Is my screen visible and am I
It is
audible?
visible, yes, and you're audible.
Okay, great stuff. So, good morning, everybody. So, like Andres indicated, my presentation would be about assumptions that we use when we model. So, with advancements when it comes to your data acquisition capabilities, we find that we are in need of more quantitative and more accurate um, analysis of our results. So what we've ended up doing is going into computer modeling, and it's become a very critical part of our lives in terms of fields of engineering and basically all sciences from economic to social to environmental, etc. The availability of computers, equipment, software packages has been quite rife. And of course, it does help us to simplify the task of creating models in relatively standard programming languages. This, of course, has accelerated the growth of model usage. So it's become very, very common for engineers, scientists, and so on, of all disciplines really, to use these tools or at least some version of it. But the problem is, together with the increased usage, there's a risk of um, the model becoming so complex that we don't take note of the errors that could be introduced in terms of the assumptions. So there are many factors that can lead to distortions and incorrect usages of the model. Some of those are whether it's incomplete knowledge of the system, incorrect assumptions, interpretation, and the use of erronic data. Um, One of the main complications with models does come from incomplete and your misinterpreted assumptions, but there are two main components of assumptions that underlie a model. The one component is the basis for generating the model. The other is the assumptions made during model implementation. And that's the model implementation is really where we fit the model to the raw data. And of course, the former type of assumption, that's what influences, what the model actually represents and predicts. And the latter one is where it influences the evaluation aspect and can cause distortion during use of the models. Now, when it comes to electric vehicle forecasting, that's not without its challenges and limitations. In terms of demonstrating the impact of your assumptions on errors that could be introduced or difference in results, I've used my last project, which was on the hourly forecasting of EV demand on the load profile in the residential sector. And of course, EV forecasters, if you've been in that space, there are significant obstacles to estimating your future sales and demands. And so, of course, we have to be very careful in terms of our estimations. And as with many other areas, there's a plethora of factors that will affect our forecasts, whether it's on the policy side, on consumer preferences side, vehicle technology, charging behavior, etc. Now, the type of method I use was System Dynamics, and the software was IC Stellar Architect. And here's just an example of what we see as linear modeling. Uh, and the difference between system dynamics modeling and linear modeling. So with linear modeling, you just have an input and an output, and obviously the level of that stock will depend on what the rates are in terms of the rate of precipitation and evaporation, fairly linear. But with system dynamics modeling, you start getting feedback and causal behavior, as well as other factors then that start getting built in that can affect the system problem. this is the 8-step process that we used in terms of modeling. I'm not going to go to the detail of it, but it is available in the book that's been co-authored by myself, Andres, and Professor Josephine Masango. If there is a need for, if anybody would like to get a copy of the book, please do write your details in the chat. In terms of the assumptions now, the first assumption, what I looked at here was if we changed, and this is important for affordability of EVs, if we look at the different income groups. So here, the Stats SA indicated that the average number of people per household was 3.34. Obviously, this is statistics, so you can work in fractions. But if we had to then not use the average of 3.34, we had to use perhaps 2.7, which was many years ago. You'd find that the number of households that we'd be dealing with that could potentially have EVs would be a lot higher. And then if you went to a higher average number of people per household, your results again could be significantly different. The second assumption test was looking at the drivetrains. So with a lot of the modeling, you find a lot of modelers, they look at the total EVs in terms of the sum of your full battery electric vehicle plus your full hybrid electric vehicle plus your plug-in hybrid. And the problem with that is that if you're going to calculate your electricity demand due to charging of these EVs, your hybrids actually don't count. They could count in terms of the number of EVs, but not in terms of what should be accounted for in terms of calculations. And that could actually affect your results drastically. And you'll find that 4 different scenarios of 0.15%, which is our current situation, or 10%, 20%, or 30% EV market penetration, the numbers that we're dealing with are vastly different to what we think we're going to expect if we had a cumulative or a summation of all of the different drivetrains. Also, what's interesting is if you're calculating electricity consumption in a year and you look at hourly charging as opposed to taking all the vehicles and charging at full capacity within a year, you find there's a significant difference in terms of the terawatt hours that you forecast. In terms of your EV battery size, yet again, these will impact your results and your forecasting. Here we have a base of what that particular household consumes in a month. However, if they start charging with a small EV, and this is assuming that we have a level 1 charger of about 3.7 kilowatts, then these would then be the differences. And you can see it can be very, significantly higher if we have a large EV, and for a large EV, we're assuming 100 kilowatt hour battery compared to a small EV battery size of about 40 kilowatts in this instance. The other assumption that will affect the forecast would be the residual capacity. So with a lot of the calculations by several parties, they assume a 0% residual capacity or residual charge in the EVs. Now, this isn't entirely correct because generally, you don't have a battery that's dead. You can have a little bit of residual capacity. So this is just an example, again, illustrating the difference in terms of your kilowatt hours within a year if you assumed there is some sort of residual capacity, in this case 35%, as opposed to charging from dead. The other assumption that we tested was looking at your charging frequency. If you charge every single day, and obviously this becomes a major issue if you're talking national numbers. This is just for a single household, but if you multiply it by the volume of EVs that we would expect, it becomes very significant and important. And what we found just from talking to several people is that people don't actually charge every day. They charge every second day or so, and that as well can create quite a over expectation in terms of what we think the consumption would be compared to what might actually be the situation. Here again, depending on the type of chargers that we have, if you have a level 1 charger or your level 2 charger, the charging profile is very different. So this is your base consumption profile in a household. However, you'll find with the green line is actually a fast charger. Here I used about a 22 kilowatt charger to then calculate the hourly charging, which then got multiplied by the tariff to try and work out what the costs would be for this household. But you can see the pattern compared to if you use a level 1 charger, which takes a lot longer. And obviously, when you bring in tariffs, depending on how long it's taking to charge, you might run into peak charging periods. So in conclusion, of course, the model is affected significantly by your model boundaries, your availability of data, how many qualitative variables you have modeled, but it's also affected by your assumptions. Now, your hourly charging versus your annualized charging of electricity demand, and this as a function of your annual distance driven, could yield a very, very large difference in results, as could the charging frequency and the battery capacity used in the calculations. So it is important that when it comes to EV forecasting in calculating volumes, your full conventional hybrids are included in calculating your consumption. All right, and that's it from my side.
Thank you, Nalini. Bit over, but I'll over